Hello, my name is Jules Tullier and I'm going to talk to you a bit more in details about VrTracker. VrTracker is a 3D position tracking device. This is meant for virtual reality to improve the experience, to be able to walk in a large room and still have a tracking to just be able to walk into your virtual environment. So what we do with a VrTracker, it is tracking an infrared light. So the infrared, it cannot be seen by your eyes, but it can be seen by special cameras, well, almost any camera. So this is an example of the infrared tracker. It is just very homemade. This is half of a ping pong ball, and this is 3D printed. So I just plug it into the battery, and this is emitting light, but you don't see it right here. It is using, you can see it a bit better here because it is this kind of violet light. This is infrared. So this is using SMD LEDs. They are surface mounted because usually through-hole LEDs have a very small angle, like about 20 degrees. But those one they have a 120 degrees angle, so it is much better to be detected by the cameras. So now the camera, this is what they look like. This is actually based on a Pixie Cam. This is a tracking camera, so there is a processor inside of it from NXP, and you can load software to track different things. This is a special firmware that can track infrared light. So I had to remove infrared filter, infrared blocking filter, and add an infrared pass filter. This is here. This is why it doesn't look very well, but this is just for testing. And I had made my own PCB to interface with the camera, but right now I am changing a lot of things, and this is why I plugged it with wires. So the camera, the tracking camera here, it talks with an Arduino Nano using an SPI connection. And it talks the Arduino, so the Arduino gets XY position for each tracker it detects. And the Arduino sends back the position using the wireless chip, the NRF24L01. But we're gonna change that pretty soon. I'm gonna talk about it later. So you can see here is an Arduino Nano, and here is the wireless chip with a large antenna. It uses a 5 volt, so it is pretty practical. And yeah, that's all I got to say about the camera for the moment. So what happens is that each camera, we need at least 2 cameras, and each camera sends XY position to the gateway. Okay, and the gateway then it is a Raspberry Pi right here, a Raspberry Pi with also a wireless chip connected to it. Okay. So the gateway receives XY position from each camera, and it computes them into XYZ position. The XYZ position, the 3D position, the real 3D position, is then sent back using Wi-Fi to the PC or the smartphone. What we are going to change pretty soon is that we want to remove the Arduino, the NRF, and replace it using this chip, the ESP2688. This is a Wi-Fi shield. So we're gonna remove this and replace it with the ESP. And here we won't have to use the gateway anymore. We can remove the gateway, and the position can be sent directly using the ESP2688 to the PC. And you can compute the position, the XY position into XYZ position directly on your PC or smartphone, because this is not huge calculus, so it won't be processor intensive. This is how the system works. What happens is that, so as I told you, each camera records XY position. It detects XY position of the blobs. And there is a calibration sequence. So the calibration sequence, it consists of recording multiple points in your real world, and you record XY position of those points for each camera, and then you gotta enter the real position in a 3 dimension. So for example, I have put some marker on my just right there, and I go with the tracker at during the calibration sequence. I put the blob on the first marker, and I record the XY position, and I say, okay, this is 0.000. Then I go to the other marker. I say, okay, it's 0.0100, for example. And you can do this with as much points as you want, as much markers as you want. And the more marker you use, the more efficient the tracking will be. Talking about efficiency, those cameras, they use a sensor that is almost HD, but as the processor is not powerful enough, it only uses 640 by 480 pixels, I think. No, by 400 pixels. But the thing is that it's pretty weird, because it does take this resolution, and then it divides it by 2 when it sends the position to the via the SPI. So we only receive 320 pixel by 200, which is not really great, and but I'm pretty sure we can improve that. The frame rate is really good, however. It is 50 frames per second, which is really good for such a kind of tracking camera. Before, I used to do this with a camera plugged into a Raspberry Pi, and the Raspberry Pi was analyzing the blob using OpenCV, and I would have a frame rate about 15 frames, which was a bit too low. You need at least 30 frames per second if you want to have a decent tracking. What else I gotta say? Improvements. Yeah, improvement we can have. We can easily add more cameras to have a bigger space covered. And what would be nice is to have a very good software architecture that would allow that. So with a better software architecture, we could have many cameras all over different rooms, and you could move around in a very big area. Another great thing to add would be, so as I told you, we're gonna remove that NRF24 and replace it with an ESP shield, ESP Wi-Fi shield. And what would be nice, it would be to add also an ESP on each blob. So what we could do is like ping this blob if we are not sure that the camera is tracking the good blob, especially when we use this with multiple person. It could ping it, so turn it on and off very quickly, and then know if it was the good blob it was tracking or not. So it would require to add an ESP on the tracker, but this is a $2 chip, so it's not very expensive, and it would add a great. It would make it much better, because it would allow to have multiple person in the same room and avoid those kind of problem. But it takes also lots of algorithm to handle that. Another a problem we have with the camera is that it is very how do I say that? The sun emits a lot of infrared, so it can bring a lot of perturbation on the tracking, and for now you got to use it in a controlled environment where you know where the infrared from the sun goes and come from. But I think that with some good algorithm this could be handled, or with a better firmware in the camera, because the firmware doesn't seem very great, but I think that pretty easily we could improve this and have better tracking. So I think this is it for now. If you want to give a hand on the project, feel free to contact me and to propose your help, because I don't have time to develop all of that by myself. But I would really love it to be a full, great, complete project. Because I think this can be well. I know this had a really great experience to virtual reality, because I have tested it in a pretty big room, and this is really great when you can move around into your virtual environment. And this is fully open source and do it yourself, and there is not such thing on the market. So at least not for that price. So if you want to help me develop the system, I would be really enthusiastic with this. So don't hesitate to contact me directly on Hackaday, on my blog, on my email, whatever you want. Okay, thanks for watching, and see you soon.